Thanks for the kind introduction. I'll just take a look. This goes forth. This goes back. Okay. Yeah. Thanks for the kind introduction. I'm very happy to be here. I think there's been a lot of interesting talks yesterday and today, and so I'm very honored that I get the opportunity to give a bit of talk as well. I'm going today to talk about quantum computing in enterprise software environments. There will also be some trucks. And to start this off, I want to start by giving a short introduction on the SAP, in case you don't know our company. So SAP is the leading enterprise software company globally, and our planning solutions, they drive the world economy. We've been around for over 50 years, and our customers have earned the trust of us. We've earned the trust of them, also vice versa, I guess. And this is because we ensure that their back office processes are transactionally secure, correct, complete, and traceable. We have a lot of reach worldwide. A lot of the high revenue and important companies are our customers. I think a lot of companies present here at Bitkom as well. Also, if you think of any major franchisor company, most likely they are our customers. And yeah, our applications have a high degree of integration due to the breadth of the product portfolio and the data integration. Okay, so why is quantum computing of interest for SAP? 77% of all business transactions in the world are running on SAP systems. And that means that whenever there's anywhere in the world environmental, political, or technological change, it's most likely affecting our customers or some customers to some degree. Which means that if there's need to react, they need to do so fast and adapt their operational planning. And there are 3 steps, you could say, that are used to do this. The first one is that the customers need to realize that something has changed. So maybe if you think about a routing problem, maybe a street is blocked, or maybe if you think about if you have a factory and you need some supplies in order to build your products, then your supplies are running out of some stuff like that, because some truck couldn't get to you. And we can use pattern recognition and machine learning to recognize these situations and try to adapt to them. And once you realize that there is something changed that you need to react, it makes sense to consider your options. And in order to do this, you can simulate on how to resolve the problems. And that might give different opportunities to go on with you, to how to deviate from your usual process. And once you have these options, you want to select the best options, and that is where mathematical optimization comes into play. And we at SAP believe that all these 3 things you see on the bottom, pattern recognition, simulations, and mathematical optimization, might very well benefit from quantum computing. And so for that reason, it's of natural interest for us to look into that. So what are the requirements for quantum computing that our customers can benefit from them? And the main requirement is that quantum computing must tightly integrate into our application environment. So what does that mean? So basically, we have certain requirements for our business applications, and you can broadly separate them into 2 categories. We have business requirements and you have technical requirements. And whenever we have these requirements that we promise to our customers that we fulfill them, quantum computing also has to fulfill them, of course. And here's a list. I will get through it. So basically, the idea behind business requirements is that you are able to properly model your business processes with our software. So the business model of SAP involves not making custom software for each customer, but rather we have one big, let's say, expressive software that can fit all the requirements from the different customers, and the customers can customize them to make it work for them. So it's kind of a one-size-fits-all solution. That's our business concept from SAP, that we have this modular business software, so to say. And the idea is that for quantum this has to be the same. So we cannot fine-tune quantum circuits for a single customer and do this again for the next customer and do this again for the next customer, depending on all the various circumstances. So there might be like different options that the customers can enable or disable regarding how they work in their business. And we expect that we expect from quantum, so we need to make sure for quantum computing that we are able to cover all these cases and cover them in a way that's beneficial for the customer. So that's kind of the business requirements that we have. And that's something we can work on as SAP, but we also have a lot of technical requirements for which we are mostly dependent on the hardware vendors. So for example, customers might have processes that they have to repeat at a very high frequency. So they have to run every hour, or they have to run multiple times a day, several days. And so if you don't have access to quantum computing all this time, then we cannot offer this to our customers, because then they want to compute their solutions, and they can't because quantum is not available. So this is a hard requirement for quantum availability in this sense. Also, scalability and reliability, if you think of it as cloud qualities. Also, as we seen in the previous talk, security is also a concern that we need to require, that the customers are expecting from our software, and that we also need to expect from the hardware vendors in this sense. Also, the scale of volume is huge, so both in terms of the number of transactions per customer as well as the number of customers. So if you can think that let's say we have 1,000 customers and they all want to have their quantum run at the same time. That means you have to have availability of all these quantum machines to do this. Because you cannot tell a customer, well, okay, now you started your quantum job, wait 10 hours until it's your turn in the queue, and then you can go for it. That's not going to fly with the customers. They have the expectation that they press the button, they want to compute something, it gets computed, they get a result. And so for SAP, in enterprise software, it only makes sense to use quantum computers if we can fulfill these requirements, while at the same time, we can integrate them, and also it has to be profitable, because if it's not profitable, why would the customers bother to use it at all? So that's kind of the hard requirements that we need to impose on quantum computing. So even if your favorite quantum hardware vendor comes to you tomorrow and says, okay, I figured it out, I have a lot of logical qubits, go wild, that's not going to help you if they are not available, or if they are not scalable, if they're not reliable. If you cannot access the service, that's not what's the point. So certainly we need to figure out how to get quantum advantage, but we also need to figure out the infrastructure around it. I would like to show you the next slide, but somehow this thing, okay, now it works. Okay. I have a different slide in front of me, so that might explain the issue. Okay. With the usage pattern in mind, we integrated the IBM quantum computer tightly into our existing planning applications. And this, what you see on the right, is like a general blueprint for this. And while we did this, we had the following questions guiding our evaluation of the current state of quantum computing. So one question that arises: how do we connect the quantum computing best with our existing cloud-native application? So we are running in the cloud, we are a cloud company, we need to call the quantum computer. How does it work? How do we map the business data automatically into quantum data? This is some kind of modeling question, which also relates to finding use cases, but it's an issue nevertheless. Then when we run the quantum computation, we'll get some samples. What do we do with the samples? How do we extract the proper solution? Which is the one that we take? This is also an issue for like maintenance. So if a customer is making a ticket, you need to think about, are things reproducible? So can you debug properly? That's not clear for quantum computing, for example. If every time you run it, there's not a random seed you can fix to get the same result, anything can get back. So that's an issue to consider. Also, how does the problem complexity scale with the business problem? That's also something you have to keep in mind to make it work. And you can see on this graphic, we are starting here on the left side with some kind of application, and then we are getting the input data to the cloud and to our optimization service, and then which will transform it for our optimization engine. This is where all the math stuff happens. So we make problem modeling reformulations to make it suitable for quantum computing. And then we fast forward it to some kind of Qiskit package in the POC that we did. And in this POC, we have this QoO algorithm, which alternates between classical computation on our cloud and quantum computation on IBM's cloud. And then they iterate for some time. And then you have to route everything back. So it has to go back from Python to the optimization engine. You have to figure out what to do with the samples, map the result back to the business problem, and then return it to the actual application. And we did this seamless integration last year, and it worked. And that was a very, very good step for us to investigate this whole process. So I've talked a lot about enterprise software so far, but not so much about trucks. So let's fix this. So for this proof of concepts that I've talked about, we choose a packing scenario from our digital supply chain solution. And we have this VSO solution, vehicle space optimization, and this concerns all kinds of problems where you pack boxes into boxes. So for example, you have some products, you want to put it on pallets. Then you have the pallets, you want to put them on trucks. Then you want to have the trucks carry them around. But you could also think of shipping containers for high sea freight. That's also something you can consider. And this is what I've been alluding to before. Our software is highly customizable. So for example, if you're packing things into a truck, you have to consider, for example, axle weights. So you don't want the axles to break of your car. But if you're just packing products on a pallet, that's not an issue. So even though it's the same kind of overall problem, there's still some kind of restrictions or requirements that the customers can enable depending on the use case. And we have to consider all of these things. And yeah, as you can imagine, there's a lot of customers and a lot of products that are being packed every day worldwide. And if we can make progress using quantum computing, that would be great. Yeah, as I said before, we have integrated the quantum computer in this kind of use case. This was a bay truck scenario in this POC where the idea was that you have to assign the products into different bays. You can see those bays here on the slide. Oh, there it is. And this is mostly used by beverage companies. And as I said, the IBM quantum computer was integrated, it worked, everything was fine. You can see on the slide that it took quite a long time to resolve, but everything worked out in the end. However, the problems are naturally limited by their complexity and by their size, by the current hardware. But that's not the point. I mean, we are believing in the hardware vendors that they will figure it out, they will scale, they will do it appropriately, but still we have to do all the other things about the integration. So that's the steps you've seen before. So let's conclude. While quantum performance today is lacking, we identified lots of action items that we will address to make quantum value to our customers. So, as I said before, quantum operations are not available 24/7 right now. And I think there's going to be a long way until they get there still, which is fine for the moment. But we can think about what would it be like if it was like that. If we had the perfect logical qubits and we had perfect accessibility, we still need to prepare everything else on our side that is independent from the hardware vendors. And so we have adapted and extended our existing software to fit this quantum computing tightly into the workflow. This is good for us because it was like the first foray into this direction for us, and this is the thing we always have to do regardless of which use case we're working on. We can use this now as a real-world environment to test drive different quantum computers. So if IBM has a new chip and we get access to it, we can just plug it in the end, and then we get a new exploration of this. So this is nice as well. And we can also, by exploring these hardware vendors or the hardware that we are integrating into this workflow, we can also give feedback to the hardware vendors. So we can give them feedback on, for example, the wait time in the queue, or the availability, or the scalability, stuff like that. So I think this is valuable feedback for them, so they know what we as industry require, so that we can productize their hardware. Last but not least, we established a solid understanding on how to identify potential SAP applications for quantum enablement. And this means that we use the experiments that we gathered here to work on other use cases, other integrations into our existing products, to see how we can prepare them for potential productization. And that's it for my talk. Thank you very much.